In previous class, we discussed the 2 point of kinetic theory of gases. Which one? That is, gas consists a molecule, and we talk about the molecules has almost zero, that is negligible volume. Now we discuss the remaining point of kinetic theory of gases. We say KTZ. Okay. So our third point is they collide each other, that is they are in random motions, they collide each other, they also collide with motions, vessel. So for example, this is our vessel, okay, and this is the vessel. So they all are collide each other and also with the vessel. Say this is the vessel, and the molecules collide each other and also with the motion, means they are in random motion. Okay, random motion, like in a this is our a carom board. Okay, so this is the all part. If there is a striker, so when striker sometime hit the all the like in the pieces of the carom board, and the striker also collide with the wall of the carom board, like an example, if you understand. So they are in random motion, collide with each other and also collide with the vessel. Okay, now we talk about the second thing, that is their collision is perfectly elastic collision. Since they have perfectly elastic collision, it means there is a no loss in energy. So this implies there is a kinetic energy transfer. Okay, so and this is the first point, that is molecule are negligible, second is in a random motion, third is in perfectly elastic, and our second point is what is the pressure of gases. Since we know that pressure, what is the pressure? The meaning of pressure is, okay, what is the meaning of pressure? So let's understand. Since they are in random motion and these random motion collide with the that is in like in the wall of the vessel. Okay, there is a vessel wall, and the particles are collide with each other. Okay, the particles collide with each other and also collide with the wall. Since they are they like a bombardment in the core wall of the vessel. What I'm saying, that is the bombardment with wall bombardment with a wall of the molecules is called pressure. Means, for example, this is our chamber where is the gas in heat. So now they hit the wall of the chamber, and this bombardment, they can hitting with the ball, create a pressure on the wall, and this is called the pressure of the gas. Means like in a bombardment, like a pressure. When we suppress anything, it feels a pressure. For example, in a bus or the seat is 20 peoples, but we add the 40 people, so like in a pressure feels, like an example of the pressure feel with the wall of the bus, pressure in like an example of something, if you understand the pressure. But like more example, pressure means like in a bombardment of particles with the wall. If you understand in real life, listen, I am also study with first time. So bombardment with wall, can you explain some reason if you understanding with a real reason? So it means a bombardment with wall will create a pressure. So for example, like in say something like So no real life example came in my mind. On second, taken case when some play scotch in a room, if 100 of people playing scotch, so they bombard with the ball. This is an example of pressure. Means the what is the meaning that like you all in the room of your class and the door are closed, and the tussle with students in the class, like everyone want to out of the class. So this tussle make a chaos where all the students touch each other, also touch with wall, and they also create a pressure where they hit the wall, they hit the door. Like in this is like example, this chaos type of example of pressure. Means they also chaos with the particles want to out of the chamber, but chamber is locked. So this is create a pressure, they bombard the they hit the wall to separate out, and this hitting like and create a pressure. Okay, this is the bombardment of the wall. I hope you understand. And second thing, since it's perfectly elastic and they apply law of classical mechanics, law here is applied. So I hope you understand all 6 points. In next video we discuss the pressure of ideal gas, we discuss the van der Waals equation, and then we move on the next topic. I hope you understand. If you understand, like and subscribe. Bye bye.